All right, you guys. You told me I needed to up my game on these videos, and I'm gonna do my best to up my game. We're gonna try page one of 1.2 characteristics of graphs, and I'm gonna highlight the learning target like we always do. Today we're gonna try to identify attributes of a function from its graph. So we already know that these are all functions, and we're going to be given a graph of these functions. We're going to have to identify for certain aspects of this, and it's pretty easy, but there's some funky parts in here we got to discuss. So let's get right to it. This is going to be page one. I'm probably going to label it this learning target page one, so we know that we have one page at a time. Here's the graph we're going to use, and we can see this graph kind of alternates going up, down, up, down, up, down. But we also alternate in some other aspects as well, right? It's got numerous y-intercepts, and sometimes it's above the y-intercept, y-axis, and sometimes it's below the y-axis. And probably some of these questions are going to be tailored to that. So let's look at this. A positive interval. An interval of x values where the values of the function, that's f of x, that means the output values, the y values, are, we're just going to say, greater than 0. That means anything above up here is greater than 0. All right? Negative values, the intervals of the x values, where the values of the function, the output, the y values, are less than 0. All right. So we're going to go through and we're going to do A. The function is positive on one interval. So let's go ahead and use interval notation. And if I go around here, negative, 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 until I get to 1. So my first one is 1, and notice I'm going to use a parenthesis. This parenthesis indicates that it's not positive at 1. In fact, we realize that if I plug in 1, my output is a 0, which is neither negative nor positive. So I'm not going to include 1, and I'm going to go around, and it looks like it's positive until it gets up here, starts coming back down until 3. I'm going to end that. Again, it's not positive at 3. I'm going to do a union. I'm going to follow this till it's going positive again right there at 5. All right. Goes up. It's still positive. It's above 0. It's 1/2 back to 0 at 7. I'm going to do union again. -1 up to 0. So it looks like we've got above the line at 9, comes back down at 11, and again, there it is. There's all the values of positive. So you can see if these are the values of positive, these 3 spots, down here it's negative. So we got some negative values too, and it looks like it starts off negative. So when I have a 0, it's negative. And kind of an interesting thing that's easy to make, it really is negative right here. So at the start, I'm going to use that bracket. And it looks like it's negative until 1, where it's neither negative or positive. I start to become negative, so I'm going to do union again somewhere around 3, but not at 3, until I get to 5. I'm going to do union again. At 5, I go up and down, and at 7, I'm negative again. All the way down and back up, and it looks like at an x value of 9, I'm done being negative. All right. So the 0 functions are when your output, f of x, and know that that's the same as y. So f of x, when your outputs are zeros. So it looks like on here I've got an x value of 1, right? I'm 0 again at an x value of 3. I'm 0 again at an x value of 5. I'm 0 again at 7, 9, and 10. So let's list them. 7, 9, and 10. All right. And you know what? I should have actually listed them over here. 1, 3, 5, 7, 9, and 10. And I'm going to erase this. I made a mistake. And these are your x-intercepts. All right. So we're almost done with this page already. I'm going to come back to this graph. But look. Increasing and decreasing, and you'll be able to see the whole thing. I'm gonna not zoom in. Maybe I can kind of fit it in right there. All right. increasing. As the input values of the function increase, the output of the values of the function increase. So as I go up, it goes up. Like right here, my x values and my y values are going up. Even though my x values are going up here, my y values are going down. So decreasing, as the input of the values of a function increase, the output of the values of the function decrease. All right. So we're going to list the intervals. From here, from an x value of 0 to 2, I'm increasing. So here we go. 0 to 2, I'm increasing. All right, at 2, I'm neither increasing nor decreasing. And then I'm going to say union. Once again, from 4 to 6, my graph is going up. It's got a positive slope, we could say. You're probably familiar with that term. And then once again, from 8 to 10. From 8 to 10. All right. Decreasing is when your slope would be negative. And we can see the line going down right here. So I'm going to say from 2 to 4. Union, the line goes down from 6 to 8. 6 to 8. Union, and it looks like the line goes down from 10 to 11. Now, I gotta admit, I'm a little hazy on something. So I'm gonna underline this, and I need to check that later. I believe that neither increasing or decreasing right here. But part of my brain wants to check this point right here to find out if this is a bracket or a parenthesis. So I'm going to go back and I'm going to look at that point later and we'll find out. All right. So a turning point on this graph. Those are called maximums and minimums. I'm going to show you why. Right? If I come around here and I get a turning point, like right here would be a maximum because I start to go back down. All right. I come over here and that's a minimum because I go back up. So of all the points around it, that's the highest point. All right. So a point on the graph where the function changes from increasing to decreasing or decreasing to increasing. These results in a local max or a local minimum value. All right. How many local maximum values does it have? Well, I see 1, 2, 3 local maximums. And we're going to say those. We're going to say 3 local maximums. What is the value f of x at these? What is the output of these? All right. So I would say, I'm going to list these as ordered pairs. I'm going to say at 2, I have a value of 1. So that's the value it's asking for, that 1. I would say at 6, I have a value of 1 as well. And at 10, I have a value of 1 as well. So I'm talking about this point is 2, 1. There's my output. 6, 1. I'm not sure if you can see this. Let me move up so you can see what I'm talking about, although this makes the graph invisible. Let's do the last one. How many local minimums does the function have? Well, a local minimum means it's lower than all the other points. And even though there's not a change here, that would be a local minimum. We have a local minimum there. And I'm going to call this a local minimum as well because it's the lowest of all the points around it. So I would say there's 4 local minimums. And what is the value of f of x? So let's list them as ordered pairs. I've got 0, -1. I have 4, -1. I have 8, -1. And I have 11 and 0. And I'm going to sign off. That's page 1.